Alright guys, if you're watching the video, you're reviewing your notes, or you missed class today, I swear guys, I do a better job in class, so try not to miss class. Alright, today we're going to be doing word problems, and we're still working on systems. So remember, systems means we have two or more equations. Usually we just have two though. Alright, and here's a list from yesterday where there were just keywords on what will mean if we have to add, divide, subtract, the things that will help us out. One thing that I do want to add is if you see the word is, was, something like that, then that means you're going to use an equal sign, okay? And you'll see me referring to it during the examples. So let's do some examples. Number one, it says Julian has $5 worth of dimes and quarters with 26 coins all together. Write a system of equations to determine the number of dimes D and Q, quarters Q that Julian has. Okay, so what I don't like is that for this first one, they don't give us any keywords for this part. But here, there's a keyword where it says all together. Now, all together is actually another way to say a total of 26 coins. So if you were here in first period, actually I did have it all together here under addition. And we can add it there, all together. But that's just another word for saying total. It had a total of $26, 26 coins, and a total of $5. So when you have totals, you always set them equal to that. So we're going to set one equal to $5 and one equal to 26 coins. Now, you should include the variable for both. Remember, it's a system, so we have two equations, and it tells us that we're going to have D dimes and Q quarters. So we're going to do addition. Obviously, that was under our addition table there. D for dimes and Q for quarters. Both of these will have both variables because it's total. Now, this first one is total money, $5. So we have to include the value of each coin, the money value. So dimes are 10 cents and quarters are 25 cents. And that's not my best equation there. I'm going to rewrite it. 0.10 represents dimes and 0.25 represents the value of quarters. So in total money, I include the money. Alright, I'm not working it out and I'm not asking you to work them out on this assignment, maybe just one. And so I'll do one or two examples here when I work it out. But for now, let's just write the system. That's what I want you to focus on this assignment. All right, number two, the perimeter of a rectangle measures 48 centimeters. The length is twice the width. Write a system of equations to determine the dimensions of the rectangle. Okay, so our first equation comes from this first sentence. Now, it assumes that you know the equation for perimeter. You may or may not know it, but let me tell you what it is. The equation for perimeter is 2 times the length plus 2 times the width. That's the equation for perimeter. And it says the perimeter measures 48, so it equals 48 centimeters. Now our second sentence comes from our second equation comes from the second sentence here. It says the length, so L, that's our variable I'm using right now, is, so equals, remember, that was one of our keywords that I added there, twice the width. Well, twice means times 2, so 2W. The number always comes before the variable. Okay, and if you're not sure, up here is twice, right there, twice. Or don't forget that if you see subtracted from or less than, that's a turnaround phrase. You know, we talked about that in class yesterday. All right, for now I'm going to leave that there, and I might come back to work it out. Let's see. All right, number 3. The local theater sold 438 tickets for a play. The tickets cost $24 per adult and $10 per senior citizen. If the total receipts were $6,298, how many senior citizens were sold? Again, I'm only asking you to write or match up the system. Our first equation is going to be from this sentence. a total. It actually doesn't tell you, but you need to understand that they sold a total of 438 tickets. So we set it equal to 438, and that's including adults plus senior citizens. And I'm going to use a C for senior citizens. Then our second equation comes from the second sentence. It says, well, the second and the third one, because it gives me another total. This is going to be total money. They made a total amount of $6,298. So again, in total, it's also addition, always right. And I'm using the same variables, except that since this is total money, that's my money side, listen, cost for per adult and per senior citizen. And there's my system. Okay. All right. Number 4. Lionel works at a music store. Last week, he sold 4 more than 3 times the number of CDs that he sold this week. Lionel sold a total of 108 CDs over the 2 weeks. How many CDs did Lionel sell? So again, just so you know where I'm getting it from, total is right here under addition. So this one for sure tells us it's one of them is a total. So I'm going to start with that one because it's the easiest. He sold a total of 108 CDs. So again, we set it equal to that total. We should be adding the two things we're talking about. Now this one's kind of worded weird. So I'm just going to tell you that X is going to be the first week. I'm just going to make X the first week. And I'm going to make Y the second week. Okay, so just make sure you're reading correctly so you understand which is which. So I'm using X plus Y. Now the other one is not a total. Okay, it actually words it out very differently. So we have to read it and follow it. It says, last week he sold 4 more than 3 times the number of CDs that he sold this week. So last week he sold more. So it's always easier to start with that one, the one they sold more of. So that's the first week, so X. What does it equal? Well, we sold 4 more last week. So if I get this week and I add 4, that's going to be 4 more. But it does say 4 more than 3 times last week. So we still have to do 3 times Y. Again, as long as it's touching, we understand it's multiplication, the 3 and the Y. We don't have to put a dot. We don't have to put an X. It's 3 times Y because it's touching Y. And there is our system. Let's go to number 5. It says the school district held a meeting for all its physical education teachers. The number of women attending was 5 more than twice the number of men attending. If a total of 53 teachers attended the meeting, how many men attended? So again, they give us a total. So I'm going to start with that one. It's always the easiest one. So we set it equal to that total. Total is always addition. And what are we talking about? Men and women. Then the other equation comes from this sentence right here. The number of women attending was 5 more than twice the number of men attending. So again, it's always easier to start with the one that's more. So women attending was, oh, there's a keyword for our equal sign, 5 more than twice, so 2 times the number of men. So we know more than is addition and twice is times 2. Times 2 what? Men. Alright, and then the next one I'm going to work out, the numbers, ignore them, is a problem like this. It says the senior class at high school A and high school B plan separate trips to New York City. The senior class at high school A rented and filled 1 van and 6 buses with 372 students. High school B rented and filled 4 vans and 12 buses with 780 students. Each van and each bus carried the same number of students. How many students can a van carry? So here, this one's actually easier, though it looks like it's a lot of stuff. It's actually easier because exactly how it's read, that's how you write it. So my first equation, or for my system, comes from this sentence, and the second one comes from this sentence. So it says 1 van, so I'm going to do X for van, so X equals van, Y equals buses, So one van plus 6 buses carried or equals 372 students. Then the next one is 4 vans, so 4x, and 12 buses carried a total of 780 students. And you're done. So that one's easier. Okay, so let me go back and work some of them out. Let's do this one. So if I want to work it out, I can do very many methods. This one actually would be easiest to do the substitution method because is already set equal to something. It's set equal to 5 plus 2m. So I can just go back and substitute it into the first equation for w. So it would be m plus, and then I'm substituting in what w equals from the second equation. Well, that equals 5 plus 2m. And since it's addition and there's nothing in front, I don't have to worry about distributing, and I can actually just take off the parentheses and combine like terms. So I have 1m plus 2m's. Together they make 3m's, and then bring down the plus 5. And then there I can solve for m. So I'm going to subtract a 5, subtract a 5. 3m equals 48. Divide by 3, m equals 16. Okay, so 16 men attended, and if for some reason they would ask me to find the women, then I can just go back in here, and in place of m, I would plug in 16, and I would solve for w, or just subtract 16 from 53, and the rest would be women that went. Okay, so that was the substitution method. Now, let's do elimination, but let me do it with smaller numbers. Ugh. I guess none of them are set up great for elimination. Well, let's do this one. Big numbers, but I'll use my calculator here. Okay, so if I want to use the elimination method, I need to have something that'll cancel out. So what I'm going to do is I'm going to multiply this top equation by -4, so then I can cancel out with this 4 right here. So then, and I'm going to write it down here. So I'm going to have -4x minus 24y, and I'm going to cheat and use my calculator, 372. So that's -1488. Then I can actually, I'm going to take that off, and I can add the two equations here. So these will cancel out or eliminate. And then these will combine to give me a -12y. And then these will combine to give me -708. And the last thing there is divide both sides by 12. So sorry, I'm using my calculator here. Okay. And let me move it up. So we divide both sides by 12, -12. We end up getting positive 59, which makes sense. We're not going to have any negative students, so I have to be positive. So y equals minus buses, 3 buses, 15 people. Now those are the hardest way of doing it. The easiest would be is to graph these two equations on Desmos Online Graphing Calculator, find where they intersect. That'll give you an x and a y coordinate, and that will give you the vans and buses. Sorry. Okay, that's it.